Our next type of reaction is a decomposition reaction, or decomp. Now, decomposition is most easily thought of as the opposite of synthesis. Synthesis is two things together become one. Decomp is the reverse of that. One thing splits up, becomes two or more. Breaks apart into multiple pieces. Now, the tricky thing, or the thing to keep in mind with decomp, is that whenever you have chemical reactions, they're always based around the concept of stability. Things are always moving to become more stable, which makes sense with synthesis. Particularly with ionic reactions and ionic bonding, we have two very unstable ions. They come together, they balance each other out. A +1 and a -1 even out. But with decomp, if the molecule or the compound existed originally, then it was already more stable than it would be apart. So breaking apart isn't natural. Usually you need some sort of catalyst for a decomp to start. Typically an added amount of energy or heat in order to break them apart. For some of these, what we'll see is that once they break apart, they can actually make more stable versions than the one they were in, and that will cause them to stay in the decomposed version. The only alternative to this would be if there was a reaction that was not happy, a compound that was not stable, and so it needed energy to happen, and then after the synthesis ended and it started to cool down or settle, then it decomposed back to its original components. A simple example of a decomposition reaction would be if we had some potassium fluoride here, KF, noted by BB8 and Ray, and then some energy goes into it and they become unstable and they split apart and separate. And now we have K and F. Another example of a decomposition reaction would be if we had something like calcium carbonate here. And now this is different because it's not strictly breaking into its components. It is actually finding a more stable form after it breaks apart. So calcium carbonate here is represented by Spider-Gwen, Katnis, and 3 doctors, calcium, carbon, and the oxygens. And if something comes in and breaks it apart, and it all destabilizes, and you've got pieces everywhere, as they start to float in, something that can happen is that they create do this and make CO2. Now CO2, along with water, is one of the two most stable molecules or compounds that you can make. And that's why it's so abundant, why there's so much of it, because it's so stable. So usually when it forms, it doesn't unform. So this isn't going to break back apart to remake your calcium carbonate, your CaCO3. So now what's left is for the other pieces to figure out what they want to become. And thankfully, calcium oxide is nice and stable enough on its own that these two can make their own thing. So the calcium carbonate breaks apart and you wind up with two smaller molecules because one is so much more stable in your carbon dioxide. You see this happen a lot with things that have hydrocarbons in them because carbon dioxide and then H2O water will do this as well.